Welcome back. This part of the video lecture deals with the components of cryptocurrency. Any currency mechanism needs certain basic functionalities. First, there must be a mechanism to secure the transactions. In cash, you basically have trust. When you hand over the money to the counter, you trust that there are no thieves that would suddenly come and take the money. You also trust the person receiving the money that they will give you the products or services they are selling. For large amounts of cash, you obviously have security personnel to establish the secure transaction. Securing the transactions in electronic traditional currency is always achieved by a third party, like a bank or a credit card company. With cryptocurrencies, the security of transaction is established by the blockchain, which is based on the technologies of peer-to-peer networking, public key infrastructure, and computing hashes. Any currency mechanism also needs a way to control the creation of additional units of the currency. With cash and with electronic traditional money, we have a central bank that controls the amount of money in circulation. You need to remember that currently all money is pure fiat money without gold standard, so central bank has total control. With cryptocurrencies, we have the cryptocurrency scheme that establishes how the new units of the currency are created. For example, for a Bitcoin, the maximum amount of money is 21 million Bitcoins. Next, I will go over the original arguments from the 2008 Bitcoin paper. You can find the paper from the link that is shown on the slide. The paper is quite easy read for any computer science student, so I highly recommend it to you all. The first argument that the paper makes is that all electronic systems run on trusted third party. The first argument that the paper makes is that all electronic commerce runs on trust-based system, and this trust is always established by a trusted third party. There is no way to do direct cash-like payments online without trusted third party at 2008. Therefore, this motivates the need of Bitcoin, as there is a need to have electronic payment system based on cryptographic proof instead of trust. One of the problems of electronic currency is the so-called double spending problem. This means that the same money can be spent more than once. If I have 10 euros and I send it to two persons A and B simultaneously, then, like cash, it has to go to the one or the other. Obvious solution to this double spending problem is only to take the only to take the transaction that occurred first. But how does one decide which transaction occurred before the other? In traditional electronic commerce, this is solved by a trusted third party, a bank or a credit card company that decides. Without trusted third party, this is more complicated. We must have all transactions public. The system, the nodes, must agree on a single valid transaction file with order. In Bitcoin, this agreement is reached so that the group with the most central processing unit power decides whether transaction A or B becomes valid. In other words, a group that first produces valid Bitcoin block, the sort of proof of work, gets to decide the next transaction order. The consequence of this is that faking transaction file requires a lot of central processing unit power. Technical details of this process will be clarified later. What follows is that Bitcoin is secure as long as honest nodes collectively control more CPU power than any cooperating group of attacker nodes. The line of argument in the Bitcoin paper continues. If a greedy attacker is able to assemble more CPU power than all the honest nodes, he would have to choose between using it to defraud people by stealing back his payments, or using it to generate new coins. He ought to find it more profitable to play by the rules, such rules that favor him with more new coins than everyone else combined, than to undermine the system and the validity of his own wealth. So what this means that in order to be able to steal money in the Bitcoin system, you need a lot of CPU power. It is argued that this CPU power is more profitably spent in mining new Bitcoins. The problem with stealing Bitcoin money is that once you start stealing it, people will not anymore use it or trust it. Therefore, you are stealing something that is suddenly becoming worthless. And your own actions are the main consequence why it is becoming worthless. Therefore, these types of frauds in the Bitcoin setup do not really work up in the large scale.